Hello, math application students. Today we're going to be talking about independent events. So if I have event A and event B, if they're independent, then that means if one of them occurs, then the other one doesn't affect that the other one's going to occur. So this says that the probability of A, given that B happens, is going to give me the probability of A. We're going to show some examples of that in a minute. Also, that the intersection of the probability of A and B is going to be equal to the probability of A times the probability of B. Now we're going to show an example of that right now. Okay, so first of all, part A, calculate the value of probability of S, and let's do that. Okay, so first we have to figure out what is the total of this. 6 plus 2 plus 3 plus 9, total is 20, right? So the probability of being inside circle S is 6 plus 2 in the numerator, which is 8, over the total, which is 20. All right? Now, I can simplify this. They're both divisible by 4. 8 divided by 4 gives me 2. 20 divided by 4 gives me 5. That simplifies to 2/5. All righty? Now, the probability of S given M. Okay, so what this means is imagine that in my circle I only have circle M. Okay, we know that this part is 3 and this part is 2. So what is the total? The total is not 20 because we don't care about the 6 and the 9. Our total here is 5. That's my denominator. Now, what's the part that's S? This part here is part of S, circle S, right? And that's going to be equal to 2. So does this meet this first relationship? The probability of A given B is the probability of A. The probability of S is probability of S given M. This is the same relationship. Okay, let's try question B. What's the probability of M? Okay, to be an M, it's 2 plus 3. My numerator is 5. My denominator is 20. Okay, that simplifies to 1/4, right? All right. So let's see. What's the probability of S times the probability of M? Okay, so 2/5 times 1/4. What is 2/5 times 1/4? That gives me 2 over 20. That simplifies to 1/10. Okay, now let's see if this matches the intersection. The probability of S intersection M. Okay, the probability of S intersection M is the football portion, the part where they overlap. That part is 2 over my total, which is 20. 2 divided by 20 simplifies to 1/10. And these two values here are the same as the intersection is equal to the probability of A times the probability of B. So since those are the same, this is independent. All right, and your homework is going to be applying this relationship or this relationship. If you have troubles, watch this video again. Okay, let's look at the next part. Okay, this one is the same as what we just did here, so this is independent. Okay, so let's try this formula here. What is the probability of A? The probability in circle A, okay, first we need the total. 10 plus 5 plus 1 plus 3. My total is 19. Okay, probability of A is 10 plus 5, which is 15 over 19. The probability of B is equal to 5 plus 1, which is 6 over 19. the probability of A intersection B is going to be 5 over 19. What is the probability of A times the probability of B? That gives me 15 over 19 times 6 over 19. Now let's just think before we do some calculations. Is this times this going to be equal to 5 over 19? Is probability of A times the probability of B going to equal the intersection like the formula says it should? Is this times that going to be equal to this? No. So when you see that, I already know that it's not going to simplify to this, so it's not independent. All right, let's look at the next example. Okay, our total here, 2 plus 12 plus 6 plus 1 equals 21. Okay, what's the probability of A? My numerator is 2 plus 12, which is 14, over 21. The probability of B is equal to 12 plus 6. My numerator is 18 over 21. What's the intersection? The intersecting part is 12 over 21. Now let's see. Is the probability of A times the probability of B going to be equal to 12 over 21? Well, let's see. 14 over 21 times 18 over 21. Is that going to give me 12 over 21? Well, we could simplify these fractions because 7 goes into 14 twice, and 7 goes into 21 3 times. So I've got 2/3, right? And let's see, 3 goes into 18 6 times, and 3 goes into 21 7 times. And let's see, I can simplify this a little further. 3 goes into 6 twice, right? So 2 times 2 gives me 4, and my denominator is going to give me 7. Is that the same as this? 12 over 21, they're both divisible by 3, which gives me 4/7. So are these the same? Yes, they are. So whenever you have the intersection of the two circles equal to the probability of one circle times the probability of the other, when those are equal, then it is independent. So you're going to be doing a bunch of that in today's assignment. Let's do some more practice. Okay, so the Venn diagram shows the number of students in Spanish, hola, Italian, buongiorno, both of these language and neither language. A student is chosen at random in the class. S represents Spanish, I represents Italian. Okay, what's the probability of speaking Spanish? Okay, first of all, 15 plus 5 plus 2 plus 6, my total is 28. Okay, probability of speaking Spanish, 5 plus 2, that's going to be 7 out of 28. Probability of speaking Italian, 2 plus 6, it's 8 out of 28. Okay. Probability of speaking Spanish, given that you speak Italian. So that means I'm only inside this circle, and I don't care about what's happening there because it's given that you speak Italian. So my denominator is 2 plus 6, which is 8. And how many of these 8 people speak Spanish? 2. Okay, that simplifies to 1/4, right? Okay. Now, the probability that you speak Italian given that you speak Spanish means I'm only concerned about being in this circle here, and I don't care about what's happening over here. So what's my denominator? Given that you speak Spanish, 5 plus 2, that's my denominator, which is 7. And how many of these 7 speak Italian? 2. All right. What is the intersection of Italian and Spanish speaking? It's 2 out of the total, which is 28. Okay, let's see what goes on here. Probability of Spanish times probability of Italian. So I'm going to multiply this guy here times this guy here, and let's see if it's equal to this one here. So we have 7 over 28 times 8 over 28. Okay. Well, first of all, 7 goes into 28 4 times, and we know that 4 goes into 8 twice, right? So I end up with 1 times 2, which is 2, and over 28. And are those the same? Yes. So does it meet our representation of the intersection of A and B equals probability of A times probability of B? Here we have the intersection. Here we have that equal to each other. Yes, it's independent. Your homework may be asking if it's independent or not. You must show these calculations or I'm not going to give you credit on the assignment. Okay, let's review the previous assignment. They might have talked about we did talk about mutually exclusive. So mutually exclusive means these circles do not overlap. So the intersection of this circle and this circle has to be 0. Another way you could think about it is the union of these two circles is the probability of A plus the probability of B. So let's see, clearly just from looking at this picture, you can see that it's mutually exclusive, right? Because the intersection of A and B is equal to 0. You can also say that the probability of A plus the probability of B is equal to the probability of A union B, right? Probability of A is 3, what's our total? The total is 19. So the probability of A is 3 over 19. The probability of B is 10 over 19. Is that equal to this plus this, 3 and 10, that's going to be equal to 13 over 19. So it's mutually exclusive. Now, what's very, very important, on an IB test, they might say, show that it is mutually exclusive. And if you see that on an IB test, that means you have to write down this, or you have to write this down in order to get credit for showing that it's mutually exclusive. If you just say it is or it's not without showing, you won't get the credit. Okay? So let's look at this one here. We can probably tell that it's going to be neither, but is the probability of A intersection B, is that equal to 0? No. The intersection is 10 over, the total here is 19 also. The intersection of this over the whole circle is 10 over 19. So we already know that it's not equal to 0. So it's not mutually exclusive. All right. Now, what about the probability of A equals 3 plus 10, that's all in A, right? So 13 over 19. Probability of B equals 10 over 19. So, does the probability of A intersection B equal to the probability of A times the probability of B? Does it? Well, A intersection B is 10 over 19. Probability of A is 13 over 19. Probability of B is 10 over 19. Is this times this going to be equal this? No, it can't, because how can 10 over 19 be 10 over 19 times anything other than 1? So it's not independent. So let's answer this last question here. Can mutually exclusive events be independent? Now let's think about that. Mutually exclusive means that the intersection of A and B is going to be 0, right? If the circles don't intersect, they're mutually exclusive, the intersection probability would be 0. Now, independent events, we just said at the beginning that the probability of A intersection B is equal to the probability of A times the probability of B. Is this ever equal to 0? No, so it cannot be mutually exclusive and independent at the same time. All right, Mustangs, good luck on your homework assignment.